Picking up from what I was saying earlier, when we go to implement these systems today, we don't really think about the archival aspect of it. Archival solutions are bolted on to our IT systems as an afterthought, and the results are that it has varying degrees of success. So, you know, storage is a very specialist subject. It's very deep, and it's got different solutions for different types of problems, and archival is a specific type of that. So I'm going to talk about some of the things that are there today in terms of what you can do with an archival solution and some of the challenges you might have with it as you make that a longer term solution. I don't know if some of you have seen this type of graphic before. This is an IDC metric just showing the massive amount of data growth that's expected to be seen in the world. This isn't necessarily all the data that you're going to need to archive. It's all the data in the world. But a fraction, we don't know what fraction of that needs to be archived forever. If I send these out, will you remind me to send David Rosenthal's blog as well? It was very good. I won't go into it here, it's too detailed. But it was very good on this type of stuff and the kind of costs that will be associated with this. You'll be surprised. So archival objectives, right? There's a couple of them, right? One of them is data recovery, one of them is efficiency. Efficiency is always an imperative in IT systems and providing systems. We know that one, right? Reducing costs, resources, simplification of things. And it begins with the creation of data. This one, there's a little bit more detail in understanding what I want to talk about data recovery, because this breaks into a couple of areas. So data isn't any use to anybody if you can't first of all get it, and second of all interpret it, right? So it's no good even getting it if you can't interpret it. So this area breaks down into a couple of different subcategories. Data backup is the most common thing that people are familiar with, because it's happened as all. We've deleted a file accidentally, you ring somebody up and you're crossing your fingers hoping that they'll be able to get you that file from 5 minutes ago somehow magically. So this thing focuses on 1 year. That's important. So any of these data backup systems you're looking at that are there for that type of purpose typically are only looking at up to 1 year. They don't really keep data in them any longer than that. The next kind of category where it's still doable, it's tougher, it's not impossible, is data archival. So people move older data into this kind of category. It's no longer actively used, and generally they can keep it in systems for 7 to 15 years, and that meets a lot of people's needs. So it's focused on regulatory compliance and business needs. But for a lot of us, and I'd say most people in this room, or you wouldn't have come along today, it's this bottom one that we're looking at, and that's where the problem is. So it's when you've got to keep data forever. And this can be business need, can be a driver. Intel has a use case on that in the Timbus project, and there's other use cases like the DAMs and the eSigns and SAP's one. But this is where there's also a sentimental or cultural heritage value to keeping data, is always an immediately obvious one for people. Right, so when you come to designing maybe an archival system or thinking about it, and I've talked to a lot of people about what they do, you basically have to start with identifying and classifying your data. If you can't do that for all the data you have in the organisation, then you've got bigger problems than how you're going to implement a solution. You have to know what you're generating. You have to standardise policies across your organisation on what to keep and for how long. You have to have an information lifecycle management policy. If you have that, you have a starting point. The second type of thing then is you need to start looking at what types of data you're generating. There's two main types, structured and unstructured. And just to briefly say what the difference is, structured, the easiest way to think of it is a database, right? You're putting data in a very structured way in a certain place, and that grows at a fairly good rate. I think I have it down there, 23.6% annually is what it's growing at the moment. But unstructured data is where it's really out of control at the moment. So this is user or demand driven, people creating files and PowerPoints, like all the lovely PowerPoints we've been looking at today, for example. So they all have to be stored somewhere. And there's different solutions. I'm not going to go into these two slides in detail, but one of them is scale up storage, right? So we've seen these are better suited to you know, the structured type of data. It's standalone scale-up systems. You just add disks to them. The other one that you probably see at the back end of SharePoints and file shares, if you use that sort of stuff to dump your files onto, is typically some type of a scale-out storage architecture. So there are two of the architectures. I was talking about architectures earlier. Scale-out is the other one. All right, you add more nodes. So these nodes all come along with more storage. Basically gives you more capacity to store data. On top of that, you've optimization technologies. I'm not going to go into them in too much detail either. But other than to say, data deduplication tries to eliminate redundant data within your unstructured data. It's somewhat akin to data forensics, depending at the level that they do this at. I have the CryoFlux floppy controller in there as an example. Those guys go down to the I/O level, and often those dedupe solutions do as well, trying to eliminate redundancy in your data. Auto-tiering is this type of thing here. So auto-tiering is all about having your business critical data, which is the most important to you and most frequently accessed, at the closest level to the user and on the most expensive hardware, so with the most amount of redundancy, the highest throughput on it. And as people use data less frequently, you can migrate it down to cheaper storage layers. It's still all readily accessible, but maybe it takes longer to get to them. And there's an example there. I don't know how readable those are, but again, when we distribute the slides, I'll just point out these two figures. If you have 3 tiers of storage as shown here with data split across them in that particular configuration, they're showing an annual cost, I think there, or 3-year cost, sorry, of $18.7 million. And by introducing a few extra tiers of, you know, higher, generally as you go down here, the capacities get higher, but the access times get slower. By introducing a couple of extra tiers, they were able to get the same storage capacity for 10.5 million instead of 18.7. So these are optimization technologies that maybe your organizations are using, maybe you're not aware of them, but they're definitely things that are out there when it comes to what you can do today to manage your spiraling problems of data growth and how you go about archiving them. Your smallest layer here could be tape, for example. So you could be, when nobody has accessed something in 5 or 6 or 7 years, maybe you tape it out and you put it somewhere. That might be the cheapest way of storing huge volumes of data, as long as you're managing your tapes properly. Simplified. I don't know if there's anything simple about this, but this is something Intel has put in the public domain, showing some of the main areas of how we break up our IT business. So we call it DOME: Design, Office, Enterprise and Manufacturing. But don't focus on the detail there. What I'm trying to show you here is that there's no one solution that's going to go across your whole enterprise or organization. It's very unlikely. I said it earlier before, these bolt-on solutions at the end of an IT process, they can have varying results, right? And if you just have one approach to archiving data, it mightn't be the best fit for everything you're doing in your organization. I came across another one of these that's very similar from the Library of Congress in the States as well. So these guys, this is equivalent to some of the stuff I've showed you already. They're showing example products at each tier. This is actually what they've implemented. This is up on the public domain, by the way, if you want to go and look at it, right? These are products that they've implemented and how much storage they have at each tier. And you can see here the kind of applications that are at each tier. So, you know, you're running virtual machines and services that people are consuming right at the layer closest to them. And as you go down the thing, you're seeing less applications, because these applications are not, they're maybe, this is an offline environment. There's no applications talking live to these. Somebody has to go and get a tape out of a safe somewhere for you to get the access. But again, very good resource there if you have time to look at it and are interested. And I can't believe it, I'm on time and I'm on my last slide. So shortcomings of current architecture. So I'm not trying to put this up to criticise anybody. I'm just showing a couple of examples. I mean, if I do a Google Internet search there, good plug for Google there, they'll be delighted with me. If I go and look at that, you'll see all these people are talking about solutions. Some of these are cloud-based. These are all archival solutions. But if you scratch the surface on many of these, not all of them, but some of the ones I've shown here maybe, they're very, very good at bit preservation. So these guys are keeping redundant copies of data for you. They're checking the fixity of it. They're checking that it hasn't been altered, all that sort of stuff. They're checking that, you know, it's not corrupt and you don't have any single points of failure if a disk somewhere fails. But they're not dealing with this over time problem of making sure that the data that you're stored in there is accessible. These guys will probably keep your data forever for you, and that's very valuable. But when they hand it back to you, will you have any application or anything available to you they can read it? Right, and I think Paula is Paula here from Tesla. I was speaking to someone, Robert, I think from Robert Sharp in your group before, but you got like and just to plug you as well maybe a little bit, but Tesla are somebody that gets that very well, right? And they have launched a solution back in June, I think it was, that deals with it. So if you're looking at outsourcing your thing, look carefully at the people who understand the problem and the people who are just saying they do and are just keeping your data. That's what I'll leave you with.